This video is about HTTP and web clients, and what does that mean exactly? Well, you may or may not remember in the old days when you were typing out a URL, let's say google.com, you normally had to prepend it with an HTTP. And I don't know if you've ever thought about that or know what it is, but it stands for Hypertext Transport Protocol. And it's actually a protocol that's being used for your browser to be able to communicate with other programs on the internet. You know, of course, that your browser is a program. And when you make a web request, we talk about it contacting a server and downloading information off the server. And usually we think of that as maybe a box somewhere in another part of the world. But when we do networking at any time, any kind of networking, including this kind of networking, we're really talking about two programs communicating over a network. That is, your browser is a program, and on the server side, there is another program called the server program. There are different types of server programs that are out there, but a server program is designed to run all the time and wait for requests to come in and then to respond to those requests. So if I go to google.com, it'll visit the Google server and I'll get a Google response. Or if I want to go to nyu.edu, it'll visit the NYU server. And there's a program on the other end. Now, in order for this program, the browser, to communicate with the server program on the other side, there needs to be an understanding between those two programs. And we call this understanding a protocol. Protocol, of course, in general, just means any series of steps that two different parties are expected to take in order to communicate. For instance, diplomatic protocol, where diplomats are expected to say and do certain things in a certain order. The protocol that you follow when you visit the Queen, for example, or whatever series of steps that's been sort of set up. Well, of course, for any two programs to be able to communicate, they've got to understand how. They've got to more or less talk each other's language. And that language, even though it's not a computer programming language, that language is a protocol called HTTP, Hypertext Transport Protocol. Now, it's not too important that we know a lot of the details of HTTP, but we do need to understand the concepts behind them, and we do need to break down the HTTP request and response. Again, we're going to a particular website, and there's a series of steps that are followed. The first step is we decide what URL we want to visit, and we send a request. And we can do that through the browser, of course, just by typing the address and hitting enter. Or we may do it by clicking on a link or submitting a form. In all of these cases, a message is being sent from our browser program to the server. And the browser program is actually following that protocol, and so is the server. That's the only way that they could really usefully communicate with one another. That is through this protocol. So what is this protocol, and what do we need to know about it? Well, the first is just the general idea of client-server networking, which is that the server will begin by listening for a request. As I mentioned, the server program is always running. And so the server program sits and waits and it listens. It listens on a networking port. None of this is terribly important, but it's important to understand the concept. The server program is always listening for your request. And when a server is down, that means that the server program stopped listening for whatever reason. The server program listens for a request. The client, which is your browser, right? Your browser is the client. That's your web browser. The client sends the request and listens for a response. The server receives the request and sends back a response, and then the client receives the response and displays it. That's what's happening, of course, when I type an address here and I get back all this information and all of this stuff, the graphics and the images and everything else. That was a client-server transaction. I was the client, I sent a response to the server responded back, and my client displayed the result. What we need to know about this protocol is the different elements of the request that we can manipulate and the different elements of the response. Because our goal in this session, in this section of our class, is to allow our Python program to act like the client. In other words, we're going to take the browser out of it, and we're going to replace our browser with a Python program. I could show that to you pretty easily. In fact, I'm going to do it here in an interactive prompt just really quickly. I'm going to import requests, and then I'm going to say response equals requests.get, and then I'm going to ask for, let's say, sps.nyu.edu. And then I'm going to print the response. Now what I'm getting back, of course, is a bunch of HTML. And we need to know how to work with this HTML. We'll be doing a little more with HTML in the next section. But for now, as you can see, what I did was I initiated a request. The program actually sent the message over the network, and the server program responded, as it always does, and I was able to display the result. This is a pretty long page, a lot longer than I expected. If I go all the way to the top, if I can, I'll show you again what it looked like. We imported requests. That's a module that we'll use to allow our Python program to behave like a browser, like a web client. Then we did a GET request for this address, same way you would enter into your browser, only this is a Python program. And then we were able to get the response and use the text attribute of the response to show the result. Now, I don't want you to think that this use of requests requires that we use an interactive prompt. I was really just doing that for a demonstration. This will normally occur in a full-fledged program. What we need to be aware of are the different parts of the HTTP request and HTTP response, because there are a lot of pieces of information that get sent over the network. When we look at something like this, it looks like all we're sending is an address and all we're getting back is a big string with the HTML in it. But it's a lot more than that. There's meta information that's sent by the browser or by the client or by your client. There's other information that might be sent in different forms. And there's also something called a response code. Let's take a look at these HTTP request parts. Now for now, all we really need to do is be aware of them and understand generally what they're for. And then later we'll look at how we can manipulate this data or use it to our advantage. The first part of an HTTP request, of course, is the URL, and we just showed that that's true when you use a browser, and it's true when you're using requests. For a basic request, you need a URL. The second is a method. We used a GET method. I'm not going to talk a lot about that right now. The parameters, this might be key value pairs that you see. For example, if I go to a website like the New York Times and I click on a link, try to click on something that's not too grim. They put the byte in trilobyte, all right. You look up here, actually we see just a URL, so that's not quite what I was expecting. But if I were to go to, let's say, my homework system and click on a link from there, you'll see that there are parameters that come with the URL, and you've seen them before. For example, here, I'll take the parameters here, and I'll show them here. Here's the entire URL that leads to my homework system. Here's the URL, but there's more to it. There are a series of key value pairs here. Here are two key value pairs. One's the user ID and one's the password. And these are what we call parameters. Again, let's not worry too much about them yet. We'll come back to them in a moment. We also have something called headers. This is meta information about the request, and we'll see some of these as well as the body of the request, which may or may not be part of the request. That's data being sent to the server. Okay, so these are the parts that we just want to keep in mind. You're going to learn more about them as we go. So you may have questions about them now. Hold on to them for now, and let's just keep exploring here the basic parts. Now, when we make a request, we're expecting a response, and the response comes back from the server program. The response consists of three parts that we can identify. One is the response code. That's going to indicate whether the request was successful or not. Did we find the resource we were looking for? Did we spell the URL correctly? Did we use parameters correctly? If everything went well, we'll get a specific response code, a 3-digit response code that says how the request went. 200 means great. An error, server error, means 500. Again, don't worry too much about them. Just be aware of them. We also have the headers, which are meta information about the response, and the body of the response, which is mostly the HTML that I showed you before. Now again, you don't want to get too hung up on any one part of these yet. We'll get in a little more detail in a moment. Now on the class slides, I've included a special utility that you can use to actually take a look at the parts of the request that you made. It's something called HTTP Reflect. I wrote it myself, and if you click on a link or submit a form on this page, you'll see broken down the different parts, the parameters that were sent. And take a look up here. See the parameters up there? A equals 1, B equals 2. Those are the parameters that I sent in the request. There's no body here. User agent, we can talk about that in a little bit. And here are a bunch of headers. The headers indicate what the request was all about. Now, we're not going to go into a lot of detail, but I can discuss it more in class. Let's move ahead and talk about how we can use requests to make this kind of request, and then we'll start to talk about how you can change the headers or the body, the parameters, etc. Here's how we do it. As I showed you in the little demo, we have an import of a module called requests. Requests is just a special module for doing this kind of work. A URL to get you something. This is a URL to the Zen of Python. And then a method, which is either .get or .post, which sends the URL out over the network and waits for a response to come back. And when a response does come back, we can use the .text to see the body of the response. Now in this case, if we were to run this script, you would find that it would take the contents of the Zen of Python, which is a document on the python.org server, and save it to an HTML page, and we can actually view it. Because of course, anytime we do any of this work and we get back HTML, we can save that if we wish. We can save it to a file. For example, if I just go back to the bottom here, and I'll reinitiate my request, even though I don't need to. And if I take, instead of printing, if I save the response, and then maybe open up a file for writing, and we'll call this sps.html, and I'll open this for writing, and say .write text and wh.close, we've actually now succeeded in writing this HTML page to whatever directory we're in, which I'm going to have to check. Okay, we're in the home directory. So if we were to go to the home directory and look for this latest file and find it here under sps.html, I can double click it and it'll actually attempt to display it. Now, this particular file looks like it requires some other resources to make it look right, so we're not really seeing the way the page should actually look. But if you look closely, you see lots and lots and lots of information that was actually included on that original page, and that's because I successfully downloaded it and I'm showing it. If we were to change this to maybe the New York Times, I might get a better result. But the main idea, though, is that that HTML is viewable in a browser, and you can use it that way. The main idea here, though, right now, is that we're going to use .get to make a GET request and .text to get back text from the response so that we can then do something with it. I kind of do want to show you what would happen if I went to the New York Times. And I'll now save the text to the response, and I'm going to open this up as NY Times as a writing. I'm going to write to the file and then close the file. And then I'll go back here and I'll say nytimes.html. And now you can see again, it's not formatted correctly because there are certain resources that are missing. But as you can see, all of the text here, all of the text from the head page of the New York Times is available here. And this will be our first step into understanding how we can download a page like this and scrape it to get back its information. Now, as far as the headers, the parameters, the body are concerned, requests makes it really easy to add these to our request. And you can see in this example, which is a second example after this slide, that I am creating a dictionary that sends headers, a dictionary that sets parameters, and a dictionary that sets a body, which we call data in this example. So it's possible to manipulate the headers, the parameters, and the body using this get request. And by the way, if we ever needed to do a post request, you would just say .post. Now, what this all means, we'll slowly, gradually begin to understand. Well, what I can tell you about the parameters is that they configure the request. They're really our way of sending input data to the server program. So we can do that with key value pairs. But the headers are a little bit different. The headers actually identify the requestor. They identify what the requestor can display. Now, I'm not talking about personal information. I'm talking about information about, let's say, what browser you're using or what images you can display. Because there are a lot of different ways to contact the internet. You can use a browser on your desktop. You could use a browser on your phone, which most people do nowadays. But you could also use a client that doesn't even display any graphics, like a command line client. There are a number of those that don't even display images. So what we do with headers is that we say, hey, I'm a Mozilla browser, I'm a Chrome browser, I'm version 20.9, and I can display JPEG, GIF, TIFF, whatever I'm capable of displaying. I will tell you about that as well. That is all done with headers. We can go back to an example of working with this. Let's see. Are we sending any headers? Let's click this request link again, and let's look at HTTP Reflect, because what we're really looking at is what the browser is sending as far as parameters and a body, which we're not sending anything, and these headers. And take a look at these headers. Look, it's saying, look, I'm on a Macintosh, an Intel Mac. Why would we want to advertise that? Why would we want to tell the server about that? That's so the server can more intelligently handle our request and send us the information only that we want, or that we can display in our browser. It talks about the language that it's using. That can be really important. A header may contain a cookie, and we can manipulate that as well. So this is what headers are about. Now, you may not need to use headers right away. It really depends. But when you're trying to contact a server for the express purpose of, getting information off that server, you might need to work with the headers, because maybe the API that you're trying to contact or whatever program you're trying to contact requires that you set some headers. You can add them and work with them yourself using this requests library. And again, let's go to this longer example. Yeah. Your headers, remember one of the headers was accept. I don't know if you remember that. Your headers can be placed inside a dictionary. Your parameters, which again are configuring the request, kind of like input to the program, can be set in a dictionary here. And then the data, which is the body of the request, which we may or may not need to send. Now, when we get back a response, it's important to understand that as well. Starting with the response code. The response code is a status code that says whether the request was handled properly or not. And there are a lot of different reasons that a request might not be handled properly. One of them is 200. I'm sorry, there are a lot of different reasons. Some of them might be server related, some might be client related, like if you give it a badly formed request or it can't fulfill your request. And the status code will help you get to the bottom of what may have gone wrong with your request if you're not getting back a 200. Again, 200 means A-OK. Here we're talking about a different kind of response that you might get if there's cause for concern, if the request didn't go through. Same thing with the headers. You might actually be interested in knowing what the server program is, what kind of server a box it's working on. Is it running Linux? Is it running Windows? Is it Apache web server that you're talking to? Can be important, and we want to understand how to get those as well. We do it with .headers. And then of course the body of the response, which is response.text. So it's kind of exciting because it makes it very, very easy to manipulate these different aspects of a request and to read the results in a response. And that's all we really need to know about making these requests. It's actually pretty straightforward. It's just that you need to understand that this is a network. This is a network communication between two programs, and it's easy for things to go wrong. And you may not always get a very good error message if things do go wrong. So that's why keeping abreast of what we're doing here and becoming comfortable with it is going to be pretty important. Now, there are a couple of things that we might want to do with a browser program like the one we wrote. One of them, in other words, when we're writing a web client using requests and we're writing it as a Python program, one of the things we might want to do, as I said before, is download HTML so that we can either display it or possibly extract what we want from it. This is where we lead into web scraping. We might want to download some HTML. On the other hand, we might want to go to an API. The AlphaVantage API is always a good bet for demonstrating this, but AlphaVantage gives you back stock data for free. All you need to do is ask for it. And when you do, you may get back JSON, and you may also get back CSV. I'm not sure if the CSV is going to display properly. Let's take a look. I want to be able to go and look at the AlphaVantage CSV. I think actually it might just launch Excel. Let's find out. Here's the CSV file. Yeah, it just downloads it as a CSV, and we can open it up any way we'd like. The basic way is that it's going to come to us as a CSV file. Don't worry about this. This is just Apple. This is my Mac trying to display the data for me. But okay, so you want to retrieve JSON or CSV data from the internet using your Python program, and this is one way to do it. If you're using JSON, it's very easy. You simply take that URL that you need to get back the data, you pass it to GET, you get back a response, and then you call JSON, which actually gives you back your, the text data that was sent back, the JSON data, as an object. It'll encode it for you or turn it into an object for you to use. Again, it might look like this, and it might be somewhat complicated. But it's actually a rather straightforward way to distribute a lot of information through structures like this. And this is giving us 5-minute intervals on IBM on January 29th. Okay, so that's one special addition to requests that make things a little more difficult. That make things a little easier. And then there's another thing that we may want to do. We may want to import a CSV file and read the CSV file. As you can see, we're doing the same thing. We're taking the URL, we're passing it to GET. Looks like I have a spelling mistake here. And we're getting back the text. And then in order to read it using a CSV reader, we might need to, we would need to take the text and split it into lines and then pass those lines to CSV reader. And if we can do that, then we can work with the CSV reader if we're ever called upon to work with a with a CSV file that can be found on the internet. So besides this and handling the status code, which we've talked about, there are ways to download images and sound files and to upload files. And these are all additional features of the requests library. In fact, if you're interested in doing this, if you want to use your Python program to download information off the internet and to be able to do it in an automated way, then you're going to want to familiarize yourself with requests and possibly explore it further for other things that it can do, like setting cookies, because that can be a very powerful way to work within the internet. That is, with an automated program, a Python program that can do these things. Okay, that is basically it. We're going to go over it again in class, of course, but I did want to get you a little bit exposed to this so that we can talk about it intelligently when we